Okay, good morning, students. Today I can explain chemical bonding topic. So, in a chemical bonding, the most important one, hybridization. This is the very important in IPE examination and asking also MSET oriented questions in this hybridization topic. So, first, what is the meaning of hybridization? So, hybridization అంటే ఏంటి? What is the statement of hybridization? చూసినట్లయితే so the process of intermixing of the atomic orbitals of slightly different energies so as a redistribution of their energies resulting in the formation of new set of orbitals of equivalent energies and shape. So this is the mainly definition of hybridization. So hybridization is nothing but the intermixing of atomic orbitals. సో అటామిక్ ఆర్బిటల్స్ అనేవి ఇంటర్మిక్సింగ్ చేసినప్పుడు సో మనకి ఒక న్యూ సెట్ ఆఫ్ ఆర్బిటల్స్ అనేవి ఫామ్ అవుతాయి. కంప్లీట్గా ఒక న్యూ ప్రాపర్టీ ఉన్నటువంటి ఆర్బిటల్స్ అనేవి ఫామ్ అవుతాయి. ఆ న్యూ ఆర్బిటల్స్ మనం ఏమంటామంటే హైబ్రిడైజ్డ్ ఆర్బిటల్స్ అంటాము. సో ఆ ఫామ్ అయినటువంటి హైబ్రిడైజ్డ్ ఆర్బిటల్స్కి ఈక్వల్ ఎనర్జీ ఉంటుంది, అలాగే ఈక్వల్ షేప్ అనేది ఉంటుంది. సో దిస్ ఈజ్ ది మీనింగ్ ఆఫ్ స్టేట్మెంట్. ఓకే, హైబ్రిడైజేషన్ అంటే ద ఇంటర్మిక్సింగ్ ఆఫ్ అటామిక్ ఆర్బిటాల్స్. అటామిక్ ఆర్బిటాల్స్ని ఇంటర్మిక్సింగ్ చేసినప్పుడు అంటే ఎస్ ఆర్బిటాల్స్ని కానీ పి ఆర్బిటాల్స్ని ఇంటర్మిక్సింగ్ చేసినప్పుడు ఒక న్యూ సెట్ ఆఫ్ ఆర్బిటాల్స్ అనేవి ఫామ్ అవుతాయి. అంటే ఒక న్యూ డిఫరెంట్ ప్రాపర్టీస్ ఉన్నటువంటి ఆర్బిటాల్స్ అనేవి ఫామ్ అవుతాయి. సో దాన్ని మనం ఏమంటామంటే హైబ్రిడైజ్డ్ ఆర్బిటాల్స్ అంటాము. సో అక్కడ ఫామ్ అయినటువంటి ఆర్బిటాల్స్కి ఈక్వల్ ఎనర్జీ ఉంటుంది, అలాగే ఈక్వల్ షేప్ అనేది ఉంటుంది. సో దట్ ఈస్ ద హైబ్రిడైజేషన్ టాపిక్. సో ఇన్ దిస్ హైబ్రిడైజేషన్ ద మోస్ట్ ఇంపార్టెంట్ పాయింట్ ఏంటంటే సో హైబ్రిడైజేషన్ అనే కాన్సెప్ట్ని యూజ్ చేసుకుని యూ హ్యావ్ టు ఫార్మేషన్ ఆఫ్ ఓన్లీ సిగ్మా బాండ్. సో హైబ్రిడైజేషన్ అనేది ఓన్లీ ఏ బాండ్స్ గురించి ఎక్స్ప్లెయిన్ చేస్తుందంటే ఓన్లీ ఫార్మేషన్ ఆఫ్ సిగ్మా బాండ్ బట్ నాట్ ఫార్మేషన్ ఆఫ్ పై బాండ్. పై బాండ్ ఫార్మేషన్ గురించి ఎక్స్ప్లెయిన్ చేయదు. సో ఓన్లీ సిగ్మా బాండ్ ఫార్మేషన్ గురించి మాత్రమే ఈ హైబ్రిడైజేషన్ కాన్సెప్ట్ అనేది ఎక్స్ప్లెయిన్ చేస్తుంది. ఓకేనా? సో అలాగే మనకి హైబ్రిడైజేషన్లో డిఫరెంట్ మోడల్స్ ఉన్నాయి హైబ్రిడైజేషన్లో. సో దాంట్లో ఫస్ట్ వన్ మనకి ఎస్పి హైబ్రిడైజేషన్ ఉంటుంది, SP2, SP3, SP3D, SP3D2. ఇలా మనకి హైబ్రిడైజేషన్ అనేవి నెంబర్ ఆఫ్ మోడల్స్ ఉన్నాయి. సో దాంట్లో మనం ఫస్ట్ సో వాట్ ఈస్ ద ఎస్పి హైబ్రిడైజేషన్ అంటే ఏంటి, సో హౌ టు ఎక్స్ప్లెయిన్ ద ఎస్పి హైబ్రిడైజేషన్ అనే దాని గురించి నో ఎక్స్ప్లెయిన్ చేద్దాం. సో ద ఫస్ట్ వన్ ఎస్పి హైబ్రిడైజేషన్. సో ఎస్పి హైబ్రిడైజేషన్ అంటే ఏంటి? సో sp hybridization అంటే the intermixing of one s orbital and one p orbital to produce two new set of hybridized orbitals. సో ఇక్కడ మనకి హైబ్రిడైజేషన్లో మోస్ట్ ఇంపార్టెంట్ పాయింట్ ఏంటంటే సో మనం ఎన్ని అటామిక్ ఆర్బిటాల్స్ అయితే ఇంటర్మిక్సింగ్ చేస్తున్నామో అన్ని హైబ్రిడ్ ఆర్బిటాల్స్ అనేవి ఫామ్ అవుతాయి. ద ఇంటర్మిక్సింగ్ ఆఫ్ అటామిక్ ఆర్బిటాల్స్ ఈక్వల్ టు ద నెంబర్ ఆఫ్ హైబ్రిడైజ్డ్ ఆర్బిటాల్స్. ఈ sp hybridization అంటే the intermixing of one s orbital and one p orbital to form two hybridized orbitals. So the intermixing of s orbital, this is the s orbital. The s orbital shape is spherical and the intermixing of p orbital, this is the p orbital. So the intermixing of s orbital, the intermixing of p orbital to produce new set of hybridized orbitals. This is nothing but sp hybridized orbital. The intermixing of one s orbital, one p orbital to produce sp hybridized orbitals. How many number of sp hybridized orbitals. This is the one sp hybridized orbital. This is the another sp hybridized orbital. So how many number of intermixing? Two atomic orbitals are intermixing. So that is equal to two hybridized orbital. This one is the hybridized orbital. This one is another hybridized orbital. So how many number of atomic orbitals are intermixing? That is equal to number of hybridized orbitals. So what is the shape of the sp hybridized orbital? The shape of the sp hybridized orbital is linear shape. Linear. What is the shape of the sp hybridized orbitals? Linear shape. Okay. So what is the bond angle in the sp hybridization? The bond angle is 180 degrees in the sp hybridization. And how much percentage of s orbital and p orbital in the sp hybridization? So 50% of s orbital and 50% of p orbital. So how much percentage of s orbital and p orbital in the sp hybridization? So 50% of s orbital and 50% of p orbital. So this is the main important points of sp hybridization. So sp hybridization is nothing but the intermixing of one s orbital and one p orbital to produce two sp hybridized orbital. This is nothing but sp hybridized orbitals. This is completely different properties ఉన్నటువంటి hybridized orbitals. So what is the shape of the sp hybridization? The shape of the sp hybridization is linear shape. So the bond angle is 180 degrees. In the sp hybridization, the s character is 50% and p character is 50%. So this is the most important points of sp hybridization. So next explain the one example in the sp hybridization. So for example, you can take BeCl2 molecule. This is one of the example of sp hybridization. BeCl2 beryllium chloride. So in the BeCl2 sp hybridization is there. So because of in this, what is the structure of BeCl2? So Be, the central atom is the Be, Cl and Cl. This is the structure of BeCl2. The two sigma bonds are formed in the two sigma bonds are present in the BeCl2 molecule. In the BeCl2 molecule, the central atom is the beryllium. Beryllium surrounding how many number of sigma bonds is present? The two sigma bonds are present in the beryllium central atom. Okay. So you can take first one. The central atom is the beryllium. So the beryllium atomic number is the 4. Electronic configuration 1s2, 2s2. This is the beryllium electronic configuration. So next one, the ground state electronic configuration is 1s2, 2s2. That means 1s orbital, s subcell containing one orbital, s subcell containing one orbital. The two electrons are present. The 2s orbital, 2s, that is also having one orbital. So that is also containing two electrons. This is the ground state electronic configuration. The ground state electronic configuration means the electrons can be arranged in the orbital. S subcell containing one orbital. Here 1s containing two electrons. The two electrons is representation in the orbital. And 2s, the s subcell containing also one orbital. The 2s containing two electrons. The two electrons can be arranged in the orbital. This is the ground state electronic configuration. Next we have to write the excited state electronic configuration. Excited state electronic configuration. So what is the meaning of excited state electronic configuration? The excited state electronic configuration means the promotion of electron to the next orbital. The promotion of electron. That means here, so 1s2, 2s to 2p 0. So one is orbital having 2 electrons, the 2s orbital having 2 electrons, but here one electron transfer into the 2p orbital. That means exhausted electronic configuration. So exhausted electronic configuration here, already the 2s orbital having 2 electrons. In these 2 electrons, one electron transfer into the 2p orbital, that is nothing but exhausted electronic configuration. So because of here you want two single electrons, because of the beryllium surrounding how many number of sigma bonds is there? 2 sigma bonds is there. That's why you want two unpaired electrons or single electrons, nothing, no problem. So here beryllium central atom, the central atom containing 2 sigma bonds, that's why you want two unpaired electrons. So here pair of electrons, that's why the pair of electrons in split into single electrons, that is nothing but existed electrons. So two unpaired of electrons is there, two unpaired electrons is there. So one unpaired electron is 2s orbital, another one unpaired electron is 2p orbital. That's why this is nothing but sp hybridization. sp hybridization. So one unpaired electron 2s orbital, another unpaired electron 2p orbital. That's why this is nothing but sp hybridization. So sp hybridization means the intermixing of one s orbital. This is nothing but 2s orbital containing one electron, and next one the 2p orbital, that is also containing one electron. The both are intermixing to produce sp hybridized orbital of beryllium. This is the 2s orbital of beryllium, this is 2p orbital of beryllium. The both are intermixing to produce sp hybridized orbital of beryllium atom. So this is the single electron, this is the single electron, this is the single electron of s orbital, this is the single electron of p orbital. Okay. So this is the sp hybridization of beryllium atom. So the next one is the chlorine atom is there. In a BeCl2 molecule, two chlorine atoms is there. So the first you have to write that one chlorine atom. Atomic number 17. Electronic configuration neon, shortcut neon 3s2 3p5. That is nothing but neon electronic configuration. So next neon 3s orbital containing 2 electrons, 3p orbital containing 5 electrons, So this is nothing but px. This is the 3px orbital, this is the 3py, this is nothing but 3pz. So this is the 3pz orbital containing unpaired electron. According to valency bond theory, only unpaired electrons are involved in the chemical bonding formation. So that's why the 3pz orbital overlapping with sp hybridized orbitals of beryllium atom. So how many number of here here 2 chlorine atoms is there. So that's why 2 3pz orbitals are there. So that's why you have to first we can take sp hybridized orbital of beryllium atom. The sp hybridized orbital of beryllium atom. So next this is nothing but 3pz orbital. 3pz orbital. This is the dumbbell 3pz orbital of first chlorine atom. This is nothing but 3pz orbital of second chlorine atom. So the 3pz orbital of chlorine atom overlapping with sp hybridized orbital of beryllium atom, and the second 3pz orbital overlapping with sp hybridized of beryllium atom. So how to overlapping? Here This is the overlapping of the beryllium. This is the chlorine. This is another chlorine. So this is the sigma bond formation here, and then overlapping. This is also sigma bond formation. Okay. So that is nothing but beryllium. Sigma bond with one chlorine atom. Sigma bond with another chlorine atom. Okay. So this is the bond angle is nothing but 180 degrees bond angle and the linear shape. The shape is linear. This is nothing but sp hybridization of BeCl2 molecule. Okay, na? So next another one, sp2 hybridization. So hybridization lo second model entante sp2 hybridization. sp2 hybridization. So sp2 hybridization means the intermixing of one s orbital and two p orbitals. This is nothing but px orbital and this is nothing but pz orbital. Sorry, py orbital. So sp hybridization is nothing but the intermixing of one s orbital and two p orbitals. Okay. So here how many number of orbitals are intermixing? So 1, 2, 3. Totally 3 orbitals are intermixing. So that's why the hybridized orbitals also 3 hybridized orbitals are will be formed. The how many number of atomic orbitals are intermixing, that is equal to number of hybridized orbitals. Here 3 atomic orbitals intermixing, that's why 3 hybridized orbitals will be formed. This is the one hybridized orbital, this is another hybridized orbital, this is the another hybridized orbital. So this is nothing but 3 hybridized orbitals. This is nothing but sp2 hybridized. The sp2 hybridized orbitals. Okay. So diagram కొంచెం వంకరగా వచ్చింది. This is the sp2 hybridized orbitals. This is the 1, 2, 3. The sp2 hybridized orbitals. Here, what is the most important points of sp2 hybridization? The sp2 hybridization, the shape of the sp2 hybridization is trigonal planar. Trigonal planar shape. And what is the bond angle of sp2 hybridization? So 120 degrees is the bond angle of sp2 hybridization. 120 bond angle. So what is the character of what is the s character and p character of sp2 hybridization? So 33.33% of s character in sp2 hybridization and 66.66% of p character. So what is the s character and what is the p character of sp2 hybridization? The s character is 33.33% and the p character is 66.66% p character in the sp2 hybridization. So this is the very most important points in the sp2 hybridization. In the sp2 hybridization, totally how many number of atomic orbitals are intermixing? The 3 atomic orbitals are intermixing. How many number of hybridized orbitals will be formed? 3 hybridized orbitals will be formed. The 3 sp2 hybridized orbitals will be formed. So what is the shape of the sp2 hybridization? Trigonal planar shape is the sp2 hybridization. What is the bond angle of sp2 hybridization? 120 degrees. So what is the s character and p character in the sp2 hybridization? 33.33% of s character and 66.66% in the p character. Okay. So what is the example? Next you can see example of sp2 hybridization. What is the example of sp2 hybridization? So what is the example? So the example is BCl3 molecule. This is nothing but boron trichloride. BCl3 means boron trichloride. So what is the structure of BCl3? The structure is this is the structure of BCl3, trigonal planar shape. In a BCl3 molecule, the central atom is the boron. The 3 sigma bonds is there. Boron surrounding how many number of sigma bonds is there? The 3 sigma bonds is there. Okay. So how to formation of these 3 sigma bonds around the boron atom? So according to hybridization concept, how to formation these 3 sigma bonds around the boron central atom. Okay. So now explain. So boron atomic number 5, electronic configuration 1s2, 2s2, 2p1. This is the electronic configuration of boron. So next one, ground state electronic configuration is ground state electron configuration is 1s2, 2s2, 2p1. So 1s orbital having 2 electrons, 2s orbital also having 2 electrons, 2p orbitals also having 1 electron. Okay. So here in a BCl3 molecule, the central atom is the boron. The boron containing how many number of sigma bonds is there? 3 sigma bonds is there. That's why you want 3 unpaired electrons. You want 3 unpaired electrons. But here how many number of unpaired electrons is there? 1 unpaired electron is there. Only one unpaired electron. So that's why you have to want again 2 unpaired electrons. So that's why you have to write the excited state electronic configuration now. Excited state electronic configuration. So 1s2, 2s. Here 2 electrons is there. In 2 electrons, 1 electrons transfer into the 2p orbital. That's why 2s1. Here 2p, 1 electron transfer 2p2. This electron transfer into this is the 2p, this is the 2px, this is the 2py, this is nothing but 2pz. The transfer of electron into 2py orbital. This is 2px, this is 2py. So now how many number of unpaired electrons is there? 3 unpaired of electrons is there. So because of you want 3 unpaired of electrons, because of the boron surrounding how many number of sigma bonds is there? 3 sigma bonds is there. That's why you want 3 unpaired of electrons is there. So now you have to write the excited electronic configuration. Okay. So here 3 unpaired of electrons, one unpaired of electron is there in 2s orbital, and 2 unpaired of electrons is there 2p orbital. So that is nothing but s1. This is 2p, sp2 hybridization. This is nothing but sp2 hybridization. Because of s orbital containing 1 unpaired electron, the p orbitals, 2 p orbitals containing 2 unpaired of electrons. That's why sp2. This is nothing but sp2 hybridization. Okay. So sp2 hybridization means 1s orbital, the intermixing of 1s orbital. 1s orbital means 2s orbital, 1 unpaired of electron intermixing with 2p orbitals. That is nothing but first one 2px1 orbital, and second one 2py1 orbital intermixing. So the 3 atomic orbital intermixing, how many number of hybridized orbitals will be formed? The 3 hybridized orbitals will be formed. 3 unpaired of electrons. This is the sp2 hybridized orbitals. So the three hybridized orbitals containing three unpaired electrons is there. Okay. So next one, in a BF3 molecule, sorry, BCl3 molecule, how many number of chlorine atoms is there? 3 chlorine atoms is there. Next we can take one chlorine atom, atomic number 17, electronic configuration, neon shortcut, so 3s2 3p5. This is the outermost electronic configuration or valence shell configuration. So you can take valence shell electronic configuration. According to valency bond theory, the valency shell electrons are involved in the bond formation. Okay, that's why we can take only valence shell electronic configuration. Again, in this valence shell electronic configuration, only you can take unpaired of electrons. Unpaired of electrons are involved in the chemical bonding formation. Okay, so the 3s having two electrons. This is nothing but a pair of electrons. P means 3 orbitals. This is nothing but 3px. This is nothing but 3py. This is nothing but 3pz. So 5 electrons is there. 1, 2, 3, 4, 5. This is the pair of electrons. This is also pair of electrons. This is nothing but unpaired electrons. The 3pz orbital containing one unpaired of electrons. How many number of chlorine atoms is there? 3 chlorine atoms there. 3 chlorine atoms, 3 3pz unpaired electrons. This 3pz orbital overlapping with sp2 hybridization of boron atom. Okay. So now here this is the sp2 hybridization of boron atom. So overlapping with 3pz orbitals. This is the first 3pz chlorine atom. 3pz of first chlorine atom. Next this is the 3pz of second chlorine atom. Next this is the 3pz of This is 3pz of third chlorine atom. So overall the 3 chlorine atoms రాస్తాను ఇక్కడ. This is the sp2 hybridization of boron atom. This is the first chlorine atom of 3pz. This is second chlorine atom of 3pz. This is the third chlorine of 3pz. So these 3 chlorine atoms is overlapping with 3 hybridized orbitals. This first chlorine atom overlapping. This is the second chlorine atom of 3pz orbital overlapping. This is the pz of third chlorine atom. So finally, what is the bond structure of here? Here first sigma bond. This is the second sigma bond. This is the third sigma bond. So boron 3 sigma bonds formation with 3 chlorine atoms. So the bond angle is 120 degrees. The bond angle is 120 degrees. The shape is trigonal planar. The trigonal planar means this is the trigonal planar. Triangle shape. The 3 atoms are present in one plane. So that's why this is the shape of the name is trigonal planar. Okay. So this is the sp2 hybridization of boron atom. అండ్ sp హైబ్రిడేషన్ ఆఫ్ BeCl2 మాలిక్యూల్. సో నెక్స్ట్ క్లాస్లో sp3 హైబ్రిడేషన్ గురించి sp3d హైబ్రిడేషన్ గురించి ఎక్స్ప్లెయిన్ చేస్తాను. ఓకే, థ్యాంక్ యూ.